So I found this question in Cengage, trigonometric ratios for compound angles chapter, and I thought it was pretty good since there are no actual methods there to solve this question. There are only fake methods. That is, it is a better method, but it is a shorter method. But I always think there should be a lengthy and proper method to solve the question. So for this one, you should try it first, and here is what I did. So I actually tried this question for 3 days and got on the third day. So that's how that's how much I was after it. Yeah. So let's expand the LHS RHS and take component dividendo. Yeah. So we get this. Now after reaching here also I was pretty confused what to do. So here I took componendo and dividendo. So when we take that we get after here I realized something, and I realized if we factorize the numerator and denominator we'll get terms purely in sine alpha, cos alpha, and sine beta, cos beta, which we actually need so that we can find out this expression, because nowhere here the terms are mixed, right? So let's do it and factor this out. So if you look carefully, I'll just factor this out already. I think you should have done that much. Right, so we get this as the numerator, and on the denominator we'll get just the opposite. Right, so now we have pure terms in alpha, beta, and we are still one step off. So I think that step would be to square these terms. Now squaring these terms may seem like a humongous task, but believe me, it's not. So let's do it. So I'll just note down a little property here. Uh, yeah, so that's sine alpha plus cos alpha square is equal to 1 plus 1 plus sine 2 alpha, and the same way sine alpha minus cos alpha square is equal to 1 minus sine 2 alpha, right? So these are the two properties I'm going to use here. So when we square this, we just get a pretty normal 4 here, and we get 1 plus sine 2 alpha times 1 plus sine 2 beta upon 1 minus sine 2 alpha times 1 minus sine 2 beta over here. Now we are still off, but I think you can see what I was talking to you about. This term right here, we are getting kind of close to it. So let's cross multiply now. That is also a pretty bad thing to do here, but so 1 plus sine 2 alpha plus sine 2 beta. It's just algebra from here now on, so you can just skip or fast forward the video. So be a plus. Yeah, so now we just need, I just want this term, so I can substitute there. If you look, if we take the LCM, we'll get sine 2 alpha, sine 2 beta, and if we substitute this, we should arrive at the answer, hopefully. Yeah, so let's take all of it here. So we'll get minus 3 plus 5 sine 2 alpha plus sine 2 beta is equal to 3 sine 2 alpha sine 2 beta. Yeah, and now if we just find the value of sine 2 alpha sine 2 beta, that is equal to 5 sine 2 alpha plus sine 2 beta minus 3 upon 3. Yeah, so we have got this value right here. And now this expression, I'll just copy paste it. I'm too lazy to write it again. Yeah, so this expression now, we'll obviously take the LCM for it. I mean, I'll just write 2 here. Let's make this 2. Yeah, upon, we'll get 1 minus 3, the same thing, plus 9 times of what we just found out here, right? So this is where I realized, like, we'll arrive at the answer. Before this, when I was solving the question for the first time, I was like, yeah, this is gonna lead to nowhere. Anyways, we'll substitute that in. Minus 3 by 3, that's just 1, right? So 2 minus 3 sine 2 alpha plus sine 2 beta upon, now I'm gonna do a little mental maths here, and I'll let you guys know how I did it. So here it's 9 by 3, 3 times 15, this much, 15 times something, and minus 3 is the same bracket, so we can just write 12 sine 2 alpha plus sine 2 beta, right? And this is just minus 1 times 9, that's minus 9, minus 9 plus 1, this is minus 8. So this is still not looking good, but yeah, some of you guys may have already noticed what I'm gonna do next. Anyways, sine 2 alpha plus 1, I'll take minus 4 common, why not? Yeah, so here we get a sigh of relief, since this just gets cut and we get the answer as minus 1 by 4. So this was a pretty damn good question, I'm not gonna lie. And yeah, if you like this, let me know, and have a good day.